All right. So I'm going to pick up kind of where we left off. I talked about the derivative of sine inverse and how we get that. I'm going to show something similar for tangent inverse to show you something a little bit different for those of you that were there, and to kind of show you what it looks like for those of you that weren't. So, what does tangent inverse mean? Well, tangent inverse of x equals y is the same as saying that the tangent of y is x. And so we can use our implicit differentiation. We can use that to get what dy dx is going to be. So we're going to take this derivative. Derivative of tangent is secant squared of y. Oh, we took a derivative of y. That means we need a dy dx. And then over here, derivative of x is 1. So to solve for dy dx, it's just being multiplied by secant squared of y. And so we're going to divide and say that dy dx is 1 over secant squared of y. Well, 1 over secant is just cosine. So it's going to be cosine squared of y. And now we need to decide what cosine squared of y means. Well, let's take a look here. Tangent of y equals x. So if we draw our kind of reference triangle here, here's our angle. If tangent of y equals x, that's x over 1. And so that means x over 1 is opposite over adjacent. So x is our opposite, 1 is our adjacent. So let's put that in there. Opposite is x, and adjacent is 1. And so we can figure out what our hypotenuse is. So we want c squared equals x squared plus 1 squared. And so c is going to equal the square root, and we're going to write it as 1 plus x squared. And so from there, instead of our goal here, our point of doing this is to write this in terms of our x instead of y. 1 plus x squared. So that means cosine is adjacent over hypotenuse. And the square root of something squared is just going to be the original function. So 1 over 1 plus x squared is the rule for tangent. And just like with cosine, the rule for cosine was the same as sine except for negative. The rule for cotangent is going to be the same as the rule for tangent inverse except it's negative. All right, let's actually take some derivatives here. So these are the derivative rules themselves. You'll notice on these rules we have a u in there instead of an x. That's just saying that that's just marking so that we know that we have the chain rule happening here. We have a du dx. That means, hey, don't forget chain rule, multiply by the derivative in the inside part. And so this is, these are probably the toughest rules as far as memorizing them goes. But just remember that just like with the trig, really, you're only memorizing 3 rules. You got the sine inverse, you got the tangent inverse, and you got the secant inverse. And cosine is the same as sine except negative. cotangent is the same as tangent, except it's negative. Cosecant is the same as secant, except it's negative. And so that's what we're going to use. So refer back to this whenever we kind of outline a derivative rule here. All right. First example, we're going to do this first one together. And then we'll do about 3 or 4 of these together. And then a couple of these I'll be asking you to do on your own. So let's give these a try. First one, cosine inverse of x squared. So let's look at what our derivative is. Y prime equals. Well, derivative of cosine inverse is going to be -1 over the square root of 1 minus the thing squared. That's my outline for the derivative rule for cosine inverse. And what goes inside of the parentheses in here and gets squared? Well, it's going to be this. It's going to be x squared. So it's going to be 1 minus x squared squared. But because there's something inside of that cosine inverse, that means we need the chain rule. Multiply by our derivative of the inside part. Derivative of x squared is 2x. So if I'm doing a little bit of rewriting here, that's going to be -2x over the square root of 1 minus x squared. Squared is x to the 4th. Next, we've got y equals sine inverse of square root of 2t. So just like we did before, first off, we're going to outline our derivative rule for sine inverse. So our rule is 1 over the square root of 1 minus the thing squared. It's my outline of derivative of sine inverse. And what goes inside of the parentheses there? Well, we're taking the sine inverse of the square root of 2t. So square root of 2t. Times derivative of the inside part. Derivative of square root of 2t. Well, derivative of 2t to the 1/2. Well, something to the 1/2 means we want 1/2 times the thing to the -1/2, which means it's going to wind up on the bottom and be a square root. So it's going to be 1 over, there's going to be 2 on the bottom, and the square root's going to be on the bottom of 2t. Oh, but hold on a second. We got another chain rule inside of the chain rule because we've got this 2t that's inside of the square root. So I need to multiply by that derivative of the inside part. Derivative of 2t is 2. So be careful there. I got a function happening inside of that square root. So let's do a bit of simplifying. 2's cancel here on top and bottom. So I just have 1 on top. And then over here, I have square root of Well, I have the square root of 2t here. And then I also have the square root of 1 minus, well, square root of 2t squared is just going to be 2t. So you can either leave it like this or rewrite it distributed out. I don't care which. Cosecant inverse of x squared plus 1. All right, so our derivative rule for cosecant is negative 1 over absolute value of the thing times the square root of the thing squared minus 1. All right, what is the thing that we're working with? We're working with x squared plus 1. So x squared plus 1 is going to go in these parentheses. So that's why we had the u. The u is a placeholder that says, you know, whatever is in here, is in these parentheses, you're going to plug in wherever there's a u. The reason we choose a u is because of something that we'll talk about second semester. But something we're talking about this semester is the chain rule. Don't forget it. Times derivative of the inside part, derivative of x squared plus 1 is 2x. Just so you know, the reason that we have the x is greater than 0, and it's going to be the same thing in part E down here. The reason we have the x greater than 0 is to say that we don't need no absolute value bars. So because x is always going to be greater than 0, we can get rid of the absolute value bars here because this part's never going to be negative. So we don't need to worry about that. In fact, we could get rid of the absolute value bars anyway because x squared plus 1 is always positive anyway. But let's do some simplifying here. Negative on top is a 2x over, I'm going to get rid of the absolute value because I said we didn't need it, x squared plus 1. And then in the square root, I'm actually going to expand out and square this. And you'll see why in just a minute here. So we have an x squared, or sorry, an x to the 4th. This is expanding out x squared plus 1 plus 2x squared plus 1 minus 1. Oh, those cancel. So that means, let me actually write this off to the side. So x to the 4th plus 2x squared. That's what we have because we canceled out the plus 1 and minus 1. That equals the square root of, well, I can take an x squared out of there. And so this means that I can have a square root of x squared times the square root of x squared plus 2. And lo and behold, the square root of x squared is just x. So the point was that these ones cancel, and that means that I can factor something out so that I can get something out of the square root. I can kick something outside of the square root. And the reason that's useful is that we have a 2x on top. We've got an x squared plus 1 here. And then we decided we have an x on the outside of here times x squared plus 2. And now the x here can cancel with the x here. So we have -2 over x squared plus 1 times the square root of x squared plus 2. Yeah, let's go down to part I, because this is a really complicated problem that's going to simplify in a really nice way. All right, let's do it. We got x sine inverse of x plus square root of 1 plus 1 minus x squared. All right, that means we have a product rule to start with. So y prime equals first times derivative of the second. Derivative of sine inverse of x is 1 over the square root of 1 minus x squared plus second times derivative of the first. Derivative of x is 1. Plus, I want the derivative of square root of 1 minus x squared. Well, let's see. Derivative of square root of 1 minus x squared equals, that's 1 minus x squared to the 1/2. Okay, so that's going to turn out to be 1/2 times 1 minus x squared to the negative 1/2. But then, of course, we're not going to forget the chain rule. Times derivative of the inside part, we got a minus x squared, so we got a negative 2x as derivative of the inside part. This 2 on top here is going to cancel with this 2 on the bottom here. And so when we rewrite it, we're going to have an x on top. And we're also going to have a negative from right here. So we have a negative x on top. And then over, well, on the bottom, we're going to have a square root of 1 minus x squared. And hopefully some of you can see what's about to happen. X on top here. Sine inverse of x times 1 is just sine inverse of x. Plus a negative means we got minus. And would you look at that? These cancel, and the answer is just sine inverse x. These are probably my favorite type of derivative problems, where you have something complicated turning into something even more complicated, and then you work through it, and it cancels to something really nice. I really like these type of problems.